Yum the Sledgehammer, How American Steel Shattered Japan's Naval Supremacy. June 19, 1944, Philippine Sea, wait 37 hours. Lieutenant Junior Grade Alex Vraciu pressed his palm against the canopy of his F-6F Hellcat, feeling the vibration of 2,000 horses straining beneath cowling and metal. The blue stretched infinite before him, water below, sky above, both meeting in a trembling line that seemed to dissolve the world into pure light. Somewhere in that brightness, 300 Japanese aircraft were coming. He could not see them yet, but he could feel them, the way a man feels approaching thunder in his bones before the first crack splits the air. Behind him, 15 other Hellcats formed up in sections of 4. Behind them, the USS Lexington, not the old lady lost at Coral Sea, but her namesake, 27,000 tons of Essex-class steel commissioned just 11 months prior. Behind Lexington, 5 more carriers. Behind those, another 7. 12 carriers total, carrying over 900 aircraft, spread across 15 miles of ocean like a steel archipelago that hadn't existed 3 years before. Vraciu's radio crackled. Bandits, Angels 24, distance 40 miles, vector 270. The controller's voice carried the flatness of a man reading grocery lists, but Vraciu understood what lay beneath that studied calm. This was it, the moment when numbers met reality, when theory transformed into aluminum and fire. He pushed the throttle forward. The Hellcat surged. 3 years earlier, everything had pointed the other direction. December 7, 1941, Pearl Harbor burned. In the twisted wreckage of Battleship Row, the old order of naval warfare died. Gunmetal gray battleships settling into Hawaiian mud, their massive turrets useless against aircraft that struck from a dimension those ships weren't built to contest. But for Japan, Pearl Harbor represented more than tactical victory. It demonstrated the devastating effectiveness of carrier-based naval aviation, a doctrine they had perfected through years of aggressive expansion and combat experience in China. The Kido Butai, the first air fleet, stood as the most formidable naval striking force on Earth. 6 fleet carriers, Akagi, Kaga, Soryu, Hiryu, Shokaku, and Zuikaku. Their pilots weren't merely skilled, they were samurai of the sky. Veterans with thousands of flight hours, men who could place a bomb into a barrel from 10,000 feet or thread a torpedo through a gap a destroyer couldn't navigate. They flew the A-6M-0, a fighter so dominant in early Pacific battles that Allied pilots developed a near-mystical dread of its capabilities, its incredible range, its climbing power, its maneuverability that seemed to defy physics. Commander Mitsuo Fuchida, who led the Pearl Harbor attack, wrote in his diary that night, "We have awakened a sleeping giant, but we have also proven that our doctrine, our training, our spirit cannot be matched. The Americans build ships. We build warriors." He was half right. The Americans did build ships. But what Fuchida couldn't foresee, what no Japanese planner adequately anticipated, was the sheer scale, the crushing industrial magnitude of what American shipyards would unleash once fully mobilized. More than that, they couldn't grasp how American engineering culture would transform the carrier from an elite, specialized weapon system into something entirely different, a mass-produced instrument of overwhelming force. In 1941, the U.S. Navy possessed 7 carriers. 3 were gone by mid-1942, Lexington at Coral Sea, Yorktown at Midway, Wasp in the Solomons. Hornet followed in October. By the end of 1942, only 3 American fleet carriers remained operational in the Pacific: Enterprise, Saratoga, and the newly commissioned Essex. Japan, having lost 4 carriers at Midway, still possessed a larger carrier force and, critically, retained its corps of elite aviators. Victory remained plausible, even likely, if they could bleed American resolve through a protracted war of attrition. But in the sprawling industrial cities of the American East Coast and Gulf Coast, something extraordinary was already taking shape. The Essex-class carrier represented a philosophical shift in naval warfare as profound as the shift from sail to steam. Previous American carriers, Lexington, Saratoga, even Yorktown, were individually crafted precision instruments, each with unique characteristics, each requiring specialized parts, each built slowly, carefully, with artisanal attention to detail. Essex was different. Essex was industrial. The design emerged from a simple question posed by the Bureau of Ships in 1939. What if we had to build not one carrier, but dozens? What if we treated carriers not as rare, precious assets, but as a commodity, like tanks, like trucks, like the thousands of Liberty ships that would soon carry American power to every ocean? The answer was standardization on a scale never attempted. Every Essex-class carrier would be 872 feet long, displace 27 100-ton standard, carry between 90 and 100 aircraft, and make 33 knots. Every rivet pattern identical, every electrical conduit in the same place, every frame and bulkhead cut from the same templates. Workers at Newport News shipbuilding could be trained on specific sections, then moved to New York Naval Shipyard, or Philadelphia Naval Shipyard, or Fore River Shipyard, and find everything exactly where muscle memory expected it. But standardization alone wasn't revolutionary. The revolution lay in speed. Essex herself, CV-9, the class prototype, was laid down on April 28, 1941. She was commissioned December 31, 1942, 20 months from keel to combat readiness. Bunker Hill, launched 7 months after Essex, commissioned in May 1943, just 13 months from keel laying. Intrepid, 12 months. By 1943, American yards were launching a new Essex-class carrier every 2 months. Commander Minoru Genda, architect of the Pearl Harbor attack, later recalled the moment he first saw intelligence reports of American carrier production. "I read the numbers 3 times. Then I checked the date to ensure it wasn't an error. 12 carriers under construction simultaneously. It was incomprehensible. Our largest shipyard, Curie, could build perhaps 1 fleet carrier every 18 months, working at maximum capacity. The Americans were building one every 60 days. I remember thinking, this is not warfare, this is mathematics, and we are on the wrong side of the equation." By mid-1944, 17 Essex-class carriers were either operational or completing trials. Japanese carrier construction, meanwhile, had effectively ceased. The Taiho, their newest fleet carrier, represented technological sophistication, armored flight deck, improved damage control, but only one was completed. Resources, industrial capacity, even trained shipwrights were evaporating under the strain of a multi-front war against an opponent who outproduced Japan in steel by a factor of 12 to 1. Yet even this crushing numerical advantage would mean little without one critical element: aircraft that could win. The F-6F Hellcat looked blunt, stubby, almost ugly compared to the elegant lines of the Zero. It sat low on its landing gear, nose angled upward like a bulldog spoiling for a fight. Pilots transitioning from the earlier F-4F Wildcat often remarked on the Hellcat's size. It was bigger, heavier, almost 4,000 pounds heavier than the Zero. But that weight was armor. That weight was fuel. That weight was 650 caliber Browning machine guns with 400 rounds per gun, enough ammunition to sustain 20 seconds of continuous fire that could saw a Zero in half. Grumman Aircraft Engineering Corporation designed the Hellcat with a singular obsession: kill Zeros. Every specification emerged from brutal combat analysis of what worked, what failed, what pilots needed to survive encounters with Japan's elite aviators. The Hellcat couldn't outturn a Zero. Nothing could. Japanese fighters achieved their legendary maneuverability through extreme weight reduction, no armor, minimal fuel protection, lightweight construction that sacrificed survivability for performance. In a turning dogfight at low speed, a Zero would win. So Grumman built a fighter that didn't turn. It dove. It climbed. It absorbed punishment that would disintegrate a Zero and kept flying. The 2,000 horsepower Pratt & Whitney R2800 engine gave it a climb rate exceeding 3,000 feet per minute. Pilots learned new tactics: dive on Zeros from altitude, fire one burst, then use superior speed to zoom climb back to safety. Don't turn, don't dogfight, use altitude, speed, and patience. But the real genius lay in integration. The Hellcat was designed from its first blueprints to operate from Essex-class carriers. Its wings folded precisely to fit Essex hangar dimensions. Its landing gear could absorb the punishing stress of carrier landings day after day. Its maintenance requirements were simple enough that carrier mechanics could perform engine swaps in 3 hours. Most critically, the Hellcat was easy to fly. The Zero demanded hundreds of hours to master, responding instantly to the smallest control input, rewarding skill but mercilessly punishing error. The Hellcat was forgiving. A pilot with 100 hours could be combat effective. After 200 hours, he was dangerous. This mattered desperately because by 1944, Japan's elite pilots were gone. They died at Midway, at Guadalcanal, over Rabaul, in the grinding attrition of the Solomons campaign where Japanese air groups flew from land bases without the logistical support to recover losses. Warrant Officer Saburo Sakai, one of Japan's highest-scoring aces, later described the inexorable mathematics of attrition. Each month we lost our best pilots. Not all at once, a few here, a few there. But always the best, because the best flew the most missions, took the greatest risks. We trained replacements, yes, but training time contracted as fuel grew scarce, as experienced instructors died. By early 1944, new pilots arrived at frontline units with perhaps 100 flight hours total. Some had never fired their guns at a towed target. We sent them against American formations of 50, 60 aircraft, knowing they would not return. Not knowing became impossible, so we knew, and sent them anyway. The Americans, meanwhile, built not just carriers and aircraft, but an entire system for producing pilots. Training commands expanded from 3 bases in 1941 to over 50 by 1943. Flight training programs that once took 18 months were compressed to 9 months without sacrificing quality, because quality was embedded in aircraft design. The Hellcat's docile handling meant more pilots survived training. Its reliability meant more return from missions to accumulate experience. By June 1944, American carrier air groups contained pilots with 300, 400, even 500 flight hours. Some had been flying combat missions for 18 months. They knew the Hellcat's limits intimately. They hunted in coordinated divisions, maintaining altitude discipline, using radar vectors to position for optimal attacks. Against them came Japanese formations led by veterans, yes, but filled with 19-year-olds who had never landed on a carrier deck, who navigated by compass and watch because their training didn't include radio procedures, who flew the same Zero airframe their predecessors had flown 3 years earlier because Japan lacked the industrial capacity to develop and mass-produce a successor. The mathematical inevitability of this confrontation was brutal. And it arrived on June 19, 1944, in a stretch of ocean west of the Mariana Islands. Vratziu saw them at 0852, not individual aircraft, but a darkness against the sun, a swarm that seemed to pulse and shimmer as it approached. His division leader's voice crackled, "Tally-ho, bandits, 2 o'clock high." The Japanese formation stretched for miles. Bombers in the center, fighters above and to the flanks, a classical attack formation designed to overwhelm defenses through sheer mass. But there was something wrong about it, something Vratziu registered before conscious thought could name it. They were too close together. Japanese doctrine emphasized tight formations to concentrate firepower, but these aircraft were practically wingtip to wingtip, bunched together like moths around a streetlight. The formation integrity suggested inexperience. Pilots clustering toward their leaders, afraid to stray, unable to maintain position through subtle control inputs. Vratziu's division dove. The bounce, the initial attack from superior altitude, was textbook. 4 Hellcats plunging from 24,000 feet, sunlight at their backs, speed building past 350 knots until the whole aircraft shook with the strain. The Zero formation scattered, some breaking left, others right, a few attempting to dive away. Vratziu selected a Zero pulling up into a climbing turn, a cardinal mistake, and pressed the trigger. 650 caliber streams converged. The Zero's lightweight construction, which made it so nimble, made it desperately fragile under sustained fire. Pieces flew, control surfaces, cowling panels. Smoke erupted from the engine. The Zero rolled inverted and fell. Vratiou didn't watch. He was already looking for the next target, executing the zoom climb that would restore his altitude advantage, preparing for another diving pass. This was the doctrine: slash attacks, maintain speed, use the Hellcat's strengths. Around him, the sky dissolved into chaos. But it was a particular type of chaos, one that revealed the fundamental transformation of naval air warfare. American fighters worked in coordinated pairs and divisions, one pilot attacking while his wingman covered, then reversing roles. Japanese fighters, many flown by barely trained pilots, fought alone, each aircraft a separate entity attempting individual combat. Commander David McCampbell, commanding officer of Air Group 15 from Essex, later described the scene. It wasn't a battle, it was a harvest. The Japanese came in these huge, unwieldy formations, and our fighters just worked through them methodically. I shot down 7 that day. Some of my pilots got 6, 5. Vratiou got 6 in 8 minutes. They didn't stand a chance. Not because we were supermen, but because we had better aircraft, better training, better doctrine, and overwhelming numbers. Every advantage that mattered. Over the course of 8 hours on June 19, 1944, a day that would become known as the Great Marianas Turkey Shoot, American carrier aircraft and anti-aircraft fire destroyed approximately 350 Japanese aircraft. American losses, 30 aircraft. The mathematics were obscene, a kill ratio of better than 10 to 1. But the true devastation lay not in the numbers, but in what those numbers represented. Vice Admiral Jisaburo Ozawa commanded the Japanese carrier force during the Battle of the Philippine Sea. A skilled, aggressive officer, Ozawa had planned his operation carefully. He would launch strikes at extreme range, 300 miles, where American carriers couldn't reach him. His aircraft would attack, then land at Guam to refuel and rearm before returning to their carriers. American carriers would be destroyed while Japanese carriers remained untouched. The plan demonstrated sophisticated tactical thinking. It also demonstrated complete ignorance of how profoundly the naval balance had shifted. Ozawa launched his strikes from 3 carriers, Taiho, Shokaku, and Zuikaku, the last survivors of the Kido Butai that attacked Pearl Harbor. Against them stood Task Force 58, 7 Essex-class carriers, 8 light carriers, supported by 7 battleships, 13 cruisers, and over 50 destroyers. The force represented more combat power than existed in the entire Imperial Japanese Navy in December 1941. But numbers, while overwhelming, don't fully capture the revolution. The Essex-class carriers weren't just more numerous, they were a different kind of weapon system entirely. Each Essex carried comprehensive radar systems, air search radar to detect incoming raids at 100 miles, fighter direction radars to vector interceptors to targets, surface search radar to track enemy ships. Japanese carriers in 1944 had primitive radar, if any. American fighter directors, officers who coordinated defensive fighters from the carrier's Combat Information Center, could track dozens of aircraft simultaneously, calling out vectors, altitudes, threat priorities. Japanese fighters launched with a heading and a prayer. Essex carriers incorporated lessons learned from every previous engagement. Damage control parties trained endlessly in firefighting, flooding control, electrical system repair. Compartmentation limited fire spread. Redundant systems ensured that damage to one section didn't cripple the entire ship. The Taiho, Japan's newest carrier, was struck by a single torpedo from the submarine USS Albacore on June 19th. Poor damage control decisions led to gasoline vapor accumulation. At 15:32, the vapor ignited. Taiho exploded and sank, taking over 600 men with her. Shokaku, survivor of Pearl Harbor, Coral Sea, and Santa Cruz, was struck by 4 torpedoes from USS Kavala at 12:20. She sank 3 hours later. In a single afternoon, Ozawa lost 2/3 of his fleet carriers and over 400 aircraft, losses Japan could not replace. The American carriers didn't suffer a single hit. The Essex-class program ultimately produced 24 carriers. 8 were commissioned too late for World War II, but the 16 that saw combat participated in virtually every major operation from late 1943 onward. They struck Truk, Japan's Gibraltar of the Pacific. They covered MacArthur's return to the Philippines. They weathered kamikaze attacks at Okinawa, where their robust construction and damage control repeatedly prevented catastrophic losses that would have sunk earlier carriers. Franklin, hit by 2 bombs on March 19, 1945, suffered 807 dead and over 1,000 wounded. She burned for hours, her flight deck a twisted inferno. But she didn't sink. Her crew fought the fires, jettisoned burning aircraft, restored power, and Franklin steamed 12,000 miles back to New York under her own power. No Japanese carrier could have survived comparable damage. This resilience, this ability to absorb punishment and continue fighting, represented the final piece of the Essex Revolution. They weren't just numerous. They weren't just well-armed. They were nearly impossible to eliminate. Admiral Chester Nimitz, Commander-in-Chief of the Pacific Fleet, summarized the Essex program's impact. The Japanese began the war with a qualitative advantage in carrier aviation, superior aircraft, superior pilots, superior doctrine, but they built a system that couldn't scale, couldn't absorb losses, couldn't adapt to industrial warfare. We built a system that turned carriers into a commodity, not precious, not irreplaceable. When we lost Hornet, we commissioned Hornet II. When Lexington went down, Lexington II entered service. The Japanese couldn't do that. They lost Akagi and Kaga at Midway and could never replace what those ships represented, not just the hulls, but the air groups, the experience, the institutional knowledge. We could, and that made all the difference. The war ended on August 15, 1945. Of the 24 Essex-class carriers built, 4 were lost in combat. None. Not one Essex-class carrier was sunk during World War II, despite facing concentrated attacks, kamikazes, typhoons, and 3 years of intensive operations across the Pacific. Japanese carrier construction, meanwhile, produced 1 new fleet carrier, Taiho, and 3 light carriers between Pearl Harbor and war's end. By 1945, Japan possessed no operational carrier air groups. The institutional knowledge required to operate carrier aviation, navigation, tactics, maintenance, flight deck procedures had been lost along with the men who held it. In the decades since, historians have debated what decided the Pacific War. Was it Midway, where Japan lost 4 carriers in a single day? Guadalcanal, where attrition ground down Japanese air power? The submarine campaign that strangled Japan's economy? The atomic bombs? Each contributed. But perhaps the truest answer lies in places whose names appear rarely in popular histories. Newport News, Virginia. Quincy, Massachusetts. Philadelphia, Pennsylvania. The shipyards where, between 1941 and 1945, American industrial might transform naval warfare from an art practiced by elites into something else entirely, an industrial process that could be scaled, replicated, made unstoppable through sheer productive capacity. September 2, 1945, Tokyo Bay. Lieutenant Commander Vratsiou stood on the flight deck of USS Intrepid watching the formal surrender ceremony aboard USS Missouri, anchored a half-mile away. Around him, carriers stretched to the horizon: Essex, Bunker Hill, Hancock, Wasp, Enterprise. 11 carriers in Tokyo Bay alone, with another 6 patrolling offshore. The assembled fleet represented more carrier-based air power than had existed in the entire world in 1941. He thought about June 19, 1944, the turkey shoot, 6 zeros in 8 minutes, the moment when theory transformed into aluminum and fire. But standing here, watching the ceremony that formally ended the war, Vratsiou understood that the outcome hadn't been decided in 8 minutes of combat. It was decided in April 1941, when the first plates were laid for Essex. It was decided in the design offices where engineers chose standardization over individualism. It was decided in training commands that produced pilots by the thousand rather than dozens. It was decided in the fundamental American belief that any problem, including war, could be solved through application of sufficient resources and industrial organization. The Japanese had built the finest carrier force on Earth. They'd trained the best pilots. They'd developed tactics and aircraft that dominated the early war. But they'd built a boutique force, exquisite, lethal, and fundamentally unable to scale to industrial war. The Americans built something else, a sledgehammer. Precise? No. Elegant? Hardly. But effective in a way that transcended elegance. When you can produce a new carrier every 60 days, when you can graduate 5,000 pilots annually, when you can absorb losses that would cripple any other navy and return stronger, the outcome stops being uncertain. It becomes mathematical. Vracheu looked down at the flight deck beneath his feet. Steel plates, riveted according to standardized patterns, identical to 12 other carriers. Ugly, perhaps. Utilitarian, certainly, but utterly unstoppable. The ceremony concluded. Around Tokyo Bay, ships' horns sounded, a thunderous chorus of industrial triumph. On Intrepid's hangar deck, mechanics were already preparing aircraft for the flight home. The war was over. The age of industrial naval warfare was just beginning. Narshus, Epilogue, the legacy of the sledgehammer. The Essex-class carriers didn't retire with peace. They adapted. By the 1950s, they were launching jets. By the 1960s, they'd been rebuilt with angled flight decks and steam catapults. USS Lexington served as a training carrier until 1991, 49 years of commissioned service. USS Intrepid became a museum in New York Harbor, her flight deck now hosting school children rather than Hellcats. But their true legacy wasn't longevity. It was the doctrine they established that naval power, like all forms of industrial war, ultimately answers to production capacity. The most sophisticated weapon system is meaningless if you can only field 3 examples. The good enough solution that can be mass-produced, maintained, and crewed by men with reasonable training will, over time, overwhelm the exquisite but rare. Modern carrier warfare still follows principles established by Essex: standardized hulls, modular systems, air wings trained through systematic programs. The Ford-class carriers entering service today displace 100,000 tons, nearly 4 times in Essex, but their design philosophy remains unchanged. Build good enough. Build many. Build systems that can absorb damage and continue fighting. Japan never built another aircraft carrier. The institutional knowledge died with Taiho, Shokaku, Zukaku. The men who understood carrier operations from admiral to mechanic were gone. You can rebuild ships. You cannot rebuild knowledge lost when everyone who held it dies. The Americans learned differently. They learned that in industrial war, the decisive weapon isn't the most sophisticated. It's the one you can build faster than the enemy can destroy them. They built the sledgehammer, and the world changed.